All right, so last class we learned about fractions, equivalent fractions, multiplying and dividing fractions, adding, subtracting fractions. So we'll do a little bit more with adding, subtracting fractions, and then we're going to get into solving fractions, and that will close out chapter 6. So if I had this problem, 3x divided by 1 over x minus 1, right? So we have to be careful with here. It's not shown, but this is all in parentheses, right? So before I flip this, I want to turn that all into one fraction. So if I don't, I want to flip it in the weird way. So this becomes 3 over x divided by 1 over x minus x over x, because x over x still equals 1, right? And you notice by doing that, I get a common denominator. So now when I go to flip this, I get 3 over x times my common denominator of x now goes to the top, and my bottom becomes 1 minus x. And by finding that common denominator before I do the flip and realizing that fraction is all together, then this problem turns to be not so bad, right? Because this first x in the denominator will cancel with this second x in the numerator. And then I just get over 3 over 1 minus x, and that is the answer. So the dealing with the fractions is just being careful that you keep your polynomials and everything kind of grouped together, right? You got to be careful that you're not flipping just part of something, you're not canceling part of polynomials. That is the tricky part of all this. And it really comes down to just kind of taking some time. So, if no questions, we'll move on to another one. This was going to be a little more complicated. So if I have 3 over x plus 1 over x squared plus x all over 1 over x plus 1 minus 1 over x minus 1. So now this becomes a much trickier problem. So again, what I need to do is I'm going to work on this in parts, and then we'll bring it all back together so we can kind of see it. So I'm just going to start with everything that I have in the numerator and see if I can get that cleaned up a little bit, right? So if I just worry about that guy for now, I got to find a common denominator. So I get 3 over x plus 1 over x plus 1. I took out the common factor in that expression. And by doing that, I see both denominators now have x's, right? So the only thing the first fraction is missing is the x plus 1. So if I put in x plus 1 here, well, what I do to the bottom, I have to do to the top. And now I can combine these, and I get 3x plus 3. I distributed the 3 through everything that was in the blue, plus 1 all over x plus 1, which simplifies down to 3x plus 4 over x plus 1. All right, so there's my first blue problem. So I'll put him back in blue. That we went from there to there. Now, we go on to our denominator, and we need to simplify him down, right? Well, remember, this denominator is together, and this denominator is together, so I can't break things apart. So the easiest thing to do is just combine them. So this new denominator becomes x plus 1, parentheses, x minus 1, which means this first guy is missing the x minus 1 up top and x minus 1 on the bottom. And this one is missing the x plus 1 and the x plus 1. And by doing that, I got my common denominator. And the good news, 1 times what's in the yellow just gives me x minus 1. Now be careful, this negative is connected to that 1, so it's negative 1 times everything that's in that red. So negative 1 times x is a minus x. And then, what am I doing wrong here? Yeah, no, okay. Negative 1 times a positive 1 becomes a negative 1. Thought I missed something, sorry. Now, again, combine like terms, so this denominator becomes x plus 1, x minus 1. Notice x minus an x, the x's cancel, right? And then negative 1 minus a negative 1 becomes a negative 2. So I finally simplified the green box down, right? So now let's put it all back together. So I have my blue box, 3x plus 4, all over x times x plus 1. And then I was dividing before, so I'm going to put it like this now, dividing by a negative 2 over x plus 1, x minus 1. Now I have to rewrite it and flip it so it becomes a multiplication problem. This becomes a times my x plus. Say again?
Why are you dividing?
Because this, right, long line up here, I'm drawing in red. That means
yeah. Okay, yeah.
Good question. Yeah, definitely ask questions. This is a crazy looking problem here. So now I've got everything flipped and everything's good, right? Remember, I can't cancel parts of a polynomial, but I can cancel a whole polynomial. So this x plus 1 on the denominator will cancel with this x plus 1 in the numerator. That negative 2 cannot cancel that negative 4 because this guy is together. So my final answer will be 3x plus 4 times x minus 1 all over a negative 2x. And hopefully you had a little more room to write than I did, so you can have yours look a little bit neater than mine because I ran out of room. And then I'll give everyone a second because that was a tough one. All right, no chats, no questions, so I think everyone kind of followed along, I guess. All right. So I think we're okay to move on to 6.7. Like I said, if you go to lesson 16, lesson 17,
Lots of practice problems with answers on the class problem sheet, so you can kind of work through some of those if you want and ask questions, especially if you're not one that's doing the homework, because that will allow you some practice before the test. There'll be quite a few of these on the test, because it basically takes all of chapter 6 to solve one of these problems. So the only difference between 6.6, well, everything we've done in chapter 6 until 6.7 is 6.7 is solving. So that means all I do is I go from expressions, and now I have an equal sign. Which takes us back to our very first lesson of the semester. Just everything is fractions now. So if I have this problem, x minus 1 all over 3y, that equals 5 over 6 plus x over y squared, and I ask you to solve for x, right? Which means I need to get x all by itself, right? Now, easiest thing we want to probably do here is move the 3y. So to move him, since he's on the bottom, I am going to multiply by 3y, and then I'm going to multiply all of this by 3y, right? So then I get x minus 1 equals, and then if I distribute through, so I want to get rid of these parentheses so I can move that last x, I get 15y over 6 plus 3xy all over y squared. And now we can kind of simple things down a little bit here, right? Because I'm probably gonna have to go to another page to get all this to fit, unfortunately. Equals 15 over 6, because 3 can come out of both of those, becomes, no, I shouldn't draw it an equal sign. Let me fix that. Because we still have our x minus 1 here. That equals, yeah, so be careful not to just add an equal sign like I did, because then it's going to really make this hard to solve. 15 over 6 becomes 5 halves y. And then this y cancels that squared. So then this becomes plus 3x all over y. All right. So I'm going to try to rewrite this on another page. So everyone, I'll give you a sec to copy this down if you need to, before I open a new page so I can put it on there. So x minus 1 equals 5 halves y plus 3xy plus 3x over y. So let's get the x's together, which means I am going to subtract a 3x over y. And then I want to move this 1 over as well. So I think we've been doing algebra enough. I can do 2 steps at once. So move him over. And we're going to get x minus 3x over y equals 5 halves y plus 1. All we did was move the x over to the other side and the y to its side, right? Now, this is where we're going to get a little bit ugly here. So I think I can keep working down and have enough room here. So notice both of these have x's in them, right? Which means I can take an x to the outside and have 1 minus 3 over y equals 5 halves y plus 1. Now the x is finally by itself. So now, if I divide this side by 1 minus 3y, and divide this side by 1 minus 3y, x equals 5 halves y plus 1 all over 1 minus 3 over y. Now, that answer is correct, but it is not simplified. So now we're going back to the problems we were doing about 20 minutes ago. I need to just simplify all that. X is already gone, so I don't have to worry about the x right now. X is going to equal whatever that ends up being simplified to. So just like we had to do in the very first problem we started today's class with, this guy becomes, it's an all in parentheses again, so let's make him have a common denominator, which becomes 5y over 2 plus, and then remember 1 over 1, 1 can just be 2 over 2. So I'm going to put all that in parentheses. And then that long line here in red means to divide. And then put that in parentheses. And notice he has a y. So this 1 needs to become a y over y. So it becomes a y over y minus 3 over y. Now, since I have common denominators, I can flip these things. And I am running out of room again. This is a long problem. I like to do it as a class because it shows how all of chapter 6 comes into one equation problem. So if I rewrite this, I'm going to write 5y plus 2 all over 2. So 5y plus 2 all over 2. And then I'm going to turn this into a time, so I'm going to flip this one. So it'll become y over y minus 3. So times y all over y minus 3. Now there's nothing in common anywhere here, and it's not an add subtracting, so I don't care about its denominator, so I just multiply straight across. So if I put him in parentheses and I distribute that y through, I get a 5y squared plus 2y all over, and put him in parentheses and multiply it by 2, I get a 2y minus 6. So finally, x equals 5y squared plus 2y all over 2y minus 6. And I am not allowed to cancel those two y's because they are part of a polynomial, and I cannot cancel parts of a polynomial. So unfortunately, that problem took 3 pages. So I'm hoping you were writing. If I need to go back to any of the pages, please let me know. If you have any questions, please let me know. I am recording, so you can go back and rewatch this. And I don't mind going back now. I just need you to tell me how we're doing. I lost, perfect. So I will go back to the last page. So in green, this I copied from the previous page, right? And so what I did is I took my -1. So I had to move it to the side. I added 1. So I added 1 over here, and that's where that guy came from. And then I took my 3xy, because it's a plus, I subtracted it to move him over here with his x's, and that's where that 3x over y came from, right? And this is not supposed to be 7. It's supposed to be kind of like an arrow saying that's the next step, right? And then what I did for the next step is my 2 x's that I have circled in blue, I pulled them out as a common factor. And remember, so x times 1 gives me x, x times -3 gives me my -3x. So I didn't change it. And because this entire piece here, and I'll box it in yellow, is in parentheses, if I move it as 1, I can treat it as one thing. So I divided by that whole thing, which means then I divided the other side by the exact same thing. And then for my last step here, I found a common denominator so that I could put these things together so I can flip it because of the division sign. So from x equals that whole mess, but it's not simplified, right? Anytime you have the same letter in the numerator and the denominator, I can break it down more, right? So I then move this to the next page. Well, actually I move this to the next page so that I can simplify it down so it looks a little bit nicer, right? And that's what I did here. So I moved everything to the next page, switched it from a division to a times, which means I flip my second fraction. Then I distributed the y and the 2 through, which put it all into this final answer. I will make sure when I go through Pearson for the test, I don't put anything like this kind on the test. I'll try to put ones on the test that should be able to be solved in about 4 steps, not one that takes a page and a half. But this problem, I like to show as we go into this, and we're going to do a much simpler one here so you can kind of gain some confidence. The one problem made us go through everything we learned in chapter 6. Say again?
How are you going to do like partial credit, or are you not? Or because like you can't see work?
Yes, I got to figure that out.
Okay.
Yeah, I don't know the answer to that question, unfortunately. I'm hoping, because I think I'm going to check. I'm going to try to pick, honestly, I'm going to try to pick multiple choice ones if I can, because that way if you solve your problem and it's not one of the 4 choices, then that should tell you to kind of check your work, right? And then that will help alleviate some of that. And then some of the multiple choice answers might be some common mistakes. So if you get that one, then I know what mistake you made in your work and I can give you partial credit. That's kind of what I'm going to try to do. And we'll kind of see how this test goes. If it just does not go well, then what I'll probably try to do is make a PDF copy and email it out, and then everybody can do it and then scan, email it, or take pictures and send it back. I prefer not to do that because a lot of times when the people use their phones to take pictures of the test, it doesn't photo well, and I can't really read it anyway. So I want to try the Pearson. I'm going to try to pick problems that I think will allow me to give partial credit by which answer you pick. Does that make sense?
Yes.
Okay. Yeah, because this one's going to be a tough test. Even before we got into this situation, this is the toughest test I give in college algebra. And it's not really tough in that aspect. It's like you have to know a lot. It's you got to be careful, right? Because it's like you see here, this problem took me 3 sheets, and if I made a mistake on this very first sheet, I won't notice it all the way through, right? And that's what makes it a tough test, because there's lots of steps to these problems, and it's not as easy as just 2 or 3 lines kind of going through. There's lots of procedures, and there's lots of ways to do it. Some of you might have solved this ahead of me and went a totally different way and got the same answer. Perfectly fine, right? So lots of ways to do it, lots of steps, lots of places to make a small mistake, to lose a negative sign, to forget a variable. That's what makes it a kind of a tough test. And up till now, I mean, this has no numbers. The next problem we're going to do, we'll have a number you can actually check your answer. But all through all of chapter 6, the only one you can really check your answers is 6, 7, because that is the only one that really has an equal sign. Any other questions? All right, let's do another one then. What if I have, and I'll give you guys a few minutes to see if you can work through some of this on your own, and then I'll start going through it as well. 2x over 2x squared minus 5x minus 1 over x equals 1 over 4x minus 10. Like I said, I'll give you a minute, see if you can solve it. This does end as an integer, so there is a number answer for this problem. So everything will clean up nicely. And this would probably be kind of like the kind of problems that will be on the test. But again, you might have gone a different path. If you did, you're fine. You can keep working if you want. So one thing I did was to bring all the x's to one side. I multiplied both sides, by 4x minus 10. Kind of like the trick I showed you at the beginning of the semester to get rid of fractions. All right. I multiplied both sides by 4x minus 10. It leaves me only a 1 on the right-hand side. I took out an x out of the denominator of the first fraction because it was in common. And because by doing that, then this x and this x cancel, right? And then I'm not going to multiply these things together because I'm going to break them apart here in a minute. Actually, I'll do it real quick here. For this 4x minus 10, if I take out a 2, right? Then this becomes x minus 5. So let me erase some of this so you can kind of see my train of thought here. 2 and x minus 5, because that's what 4x minus 10 becomes. If I do that, and I go to multiply this first thing, actually disregard that. I made a mistake. We ignore all of everything I just said. I didn't realize the bottom had a 2 in it. No, it was right. I was right. 2x minus 5. Because 2 times 2x is 4x. 2 times negative 5 is 10. There we go. I was right. So then this and that one cancel. So for my first fraction, it's just 2 times 2, which is 4, right? And that other denominator is all gone. The only issue is I have to multiply all of this times that 1. So it's minus 1 times all that, and I'm just going to put it back together for now. 4x minus 10 all over x equals 1. And that's 4 over nothing. So now I can subtract this 4 from this 4. And I gotta be careful with this negative sign. I don't want to lose it in my process here. So I'm gonna put that in brackets just to keep an eye on that negative for a minute. I get a negative. I'm gonna distribute him through so I don't lose him. negative 4x plus 10 all over x equals 1 minus 4 is negative 3. Now, what I'm going to do here is if I multiply all of this by x, then that x and cancels that x. What I do to one side, I have to do to the other, so this becomes a negative 3x. So what I have now is negative 4x plus 10 equals a negative 3x. And notice, I finally got all my fractions gone. Took a minute on this problem, but I got them all gone. Now, if I add 4x to both sides, I get 10 equals x, and I'm done. All right, no chats, no one's chiming in, so I feel we're okay. All right, we'll do one more here. So if I have 5 over y equals 2 over y minus 3 plus 7 over 2y squared minus 6y. Now, I couldn't do this on the last equation, but because every one of these fractions have a y on it, what I can do right from the beginning here is subtract a 5y from both sides. Sorry, answering a question. So I bring it over. And why that helps, because 5y minus 5y is 0. And then 2 over y minus 3 plus 7 over 2y squared minus 6y. Make sure I keep that all on the bottom. Minus a 5y. And you're going to see in a minute why this is key, right? And this will help us a lot when we get into chapter 7 too. I can get any equation equals 0 if I just move everything to one side. So now, because I am adding and subtracting fractions, I have to find a common denominator, right? So before I can do that, let's simplify this problem. So I have 2 with a y minus 3 plus 7 all over. I can take out a 2y, which gives me a y minus 3 minus a 5y. So by breaking it down, I can see some things these have in common, right? I'll put him in parentheses because he's by that y minus 3 is not the same as a y, right? but I can see I have a y minus 3 in 2 of the fractions. And then I have just a y by itself in 2 of the fractions. And I have a 2 all by itself in all of them. So in my first fraction, I am missing, I don't want to do this in a different color. I am missing a 2y, right? So if I have a 2y in the bottom, I have to multiply the top by 2y, right? Because 2y over 2y is 1. That's why we can do this. This second fraction has everything, so he's good to go. We don't have to do anything with him. My third fraction has the y, but he's missing the 2, and he's missing the y minus 3. So that means I have to multiply the top by a 2y minus 3. So now by doing that, I have a common denominator. I'll give everyone a sec to write that down if they want to. All right, so I'm going to write this on the next page, all with the common denominator 2y minus 3. I won't distribute through up to, yeah, well, real quick, right? So 2y times 2 is 4y, so this becomes a 4y. And then negative 5 times 2 becomes a negative 10. So I'm going to rewrite it that way on the next page, so we can kind of see that. So I have 4y plus 7 minus 10y minus 3. Look. 4y plus 7 minus 10 parentheses y minus 3 all over 2y y minus 3 equals 0. So all I did was rewrite everything that we had on another page a little bit neater with a common denominator, since I was adding fractions. Now, this is where the 0 becomes really cool. If I multiply this whole thing by 2y y minus 3, right? If I multiply by the entire denominator, then that means all of this cancels all of this, right? Well, if I multiply 0 by the entire common denominator, 2y y minus 3, well, 0 times anything is 0. So my entire fraction just disappeared in one step. And I get 4y plus 7 minus 10 y minus 3 equals 0. And now I am back to our very first week, which seems so long ago, of just solving a linear equation. So I distribute the 10 through, I get 4y plus 7 minus 10y plus 30 equals 0. Combine my like terms, I get a negative 6y plus 37 equals 0. Subtract 37. I get negative 6y equals a negative 37. Negative, not 3y, 37. Work my computer. Then I divide through by a negative 6. And y equals 37 over 6. So there's a lot of problems today. I can do more if we would like. But the only real new lesson for today was I added an equal sign. But I have to be comfortable with all of chapter 6 to really do these problems. I have to remember how to factor. We didn't do any of the AC methods ones today. We will be doing those next class. Actually, that's all we'll be doing next class, because next class is solving quadratics by factoring. So we'll still get some more practice with those. And remembering the rules of fractions. I multiply fractions, I multiply straight across. I divide fractions, I flip the second fraction, then I multiply straight across. Add and subtract fractions, I have to first find a common denominator, then I add it, and then when I do to the bottom, I do the top. combine like terms in my numerator, my denominator doesn't change, and I'm done. And then if I get an equal sign, I gotta go through all those different types of processes until I get the variable I am trying to solve for isolated, and I actually have a solution. That is a quick rundown of what chapter 6 was all about. Very, very algebra heavy. So you gotta be comfortable with a lot of things in the first week. You gotta remember how to add and multiply numbers. So there's a lot into chapter 6, right? So if there's any part of those areas that you need some practice on, then I highly encourage you to go into Stat Lab and do some practice problems. Go to, like I said, lessons 15, 16, and 17 on the class problem sheets. And I actually have all the solutions already posted for you. You can work through some of those problems and ask questions. We still have a little more than a half hour if people have questions. But that's basically what I have. I can do another one if people want me to.
Okay. Look,
Go ahead, Matt. What?
you heard the you heard the concept about them earlier because they were two separate fractions, right?
Correct. Yes, you got to find a common denominator before you just cancel it, because if not, you won't be able to add and subtract the numerator properly. So before you get rid of the denominator, you must find a common denominator. Very good point, Matt.
Okay.
The test will be on Pearson. It will be after we finish chapter 7, so probably in 2 weeks. And yes, it will be on Pearson. I haven't written it yet, but I'm going to try, like I said, to pick problems that will give you some way to get partial credit if I can. And we'll run this test and see how it goes. I know this is how they do it online, right? Online, if you do fully online, all the tests are on Pearson and you don't get partial credit. So I'm going to try to find a way to give you some, though. The next test will be over chapters 6 and 7. So we got to finish 7 first, which we should finish here probably in the next 2 weeks. Oh, excuse me. And then we'll have our test. And then all we'll have is chapters 11 and 13 to finish out the semester.
We have a final in this class.
We do. And then I got to figure out how I'm going to do that as well still. It'll be probably on Pearson. And I will be working that out. So I'm trying to, let's see if I go to this all in one syllabus. There we go. Perfect. So let's see.
Do you need us to be in the class Zoom while taking the tests?
No, I am not dealing with all of that. No, it will be open book, open note. You'll have to finish it. I don't know if I'm putting a time on it yet. It will have to be completed that day, and it will have to be completed in one setting. So you won't be able to save it and come back to it. Once you start it, you will have to sit there and finish it. So that's what I'll probably do instead of putting a time limit on it. I'll probably open it for a 24-hour period. Sometime during that 24-hour period, you must take it. And whenever you start to test, you must finish the test.
Is it going to be on a day that we usually have class?
I will probably... I'll try. I don't know. I haven't really decided. I didn't think about that. I'll get back to you on that one. I was thinking just picking a day, but everyone's got different stuff on different days. I was thinking more of a weekend.
I would prefer to have it on a day that we had class, because like I've already set aside time for like this class. So
yeah.
Same.
But I don't know if the syllabus works that way. Like if we have to do like classes that we learn stuff. I don't know.
Yeah, I'll see how the syllabus goes. Right now, because of losing that week, I didn't plan on giving the test during class time. I bet I can open it up during that day. But I don't know how busy everyone else's schedule, how many classes they have during that day. That was my only fear. But it will not be during, if we will have class still. Even if it is that class day, we will still have class because of losing the week after spring break. That's just how I've made up the time to cover the material by not giving the test during class time.
Gotcha.
Any other question? Oh, I got some in chat. Good. Okay, nope. Those are the ones already answered. Any other questions? All right. I'm still here, so if you want me to do another problem, I can. If you want to go, you can. I am open to whatever you all want.
I've got one question.
Yeah, Jim.
Earlier, you did a problem, and it was just a subtraction with fractions, 2x over 2x squared minus 5x minus 1x. And I was trying to figure out how you solve that.
All right. Let me bring up a whiteboard so we can go through that again. Whiteboard. So give me the equation again, Jim.
2x over 2x squared minus 5x, and then minus 1x.
1 over x or just 1?
1 over x, yeah.
Yep. So first we have to find a common denominator, right?
Right,
So,
that's kind of, and
notice,
that's kind of what I was, I wasn't sure what the final, the common denominator for that would be.
so if we look at our first fraction here, notice they both have x's, right?
Yeah.
So if I pull out, was it a 2x squared?
Yeah, 2x squared.
Okay, good. I was like, this is going to be weird in a minute. So if they both have some x's, so if I pull out an x of the first equation, then I got an x on the outside and I get 2x minus 5 on the inside, right?
2x. All right, yes.
And then I have my other fraction, which is a 1 minus x. Now, by simplifying it, I see he has an x, and I see he has an x. But I also notice he has a 2x minus 5, and he does not, so I'm going to give him 1. Well, what I do at the bottom, I have to do to the top. And now I have my common denominator, because the two denominators look exactly the same. So my common denominator is x, 2x minus 5. Well, the first fraction, I didn't have to add anything, so he just stays a 2x. My second one, I added this 2x minus 5 in yellow, so I am going to take this -1 and I'm going to distribute him through, which then gives me a parentheses. Well, no, not a parentheses. When I distribute him, the parentheses go away, sorry. -1 times 2x is a minus, come on, minus 2x. -1 times a -5 becomes a +5. So this first 2x is that guy right there. So I put a red box around those two. That's where he came from. The rest of that expression came from distributing that -1 times the 2x minus 5 in yellow.
All right, that whole 2x minus 5 there, that's, all right.
That is the thing I had to add so that I could have a common denominator. And what allows me to do this mathematically is when I have 2x minus 5 over 2x minus 5, that is really just 1. All I did to that fraction is multiply it by 1. I just didn't multiply it by the number 1. I multiplied it by a equivalent fraction that equals 1. So by multiplying him by a equivalent fraction that equals 1, then I haven't changed the problem. And the reason I have to do that is because I have to get a common denominator.
All right.
So then 2x, so now going to my final expression here. The 2x minus 2x, those cancel. So my answer becomes just a 5 on the top over x, 2x minus 5 on the bottom. And that is my final answer in the black box. I don't know why I have an equals there, get rid of him.
X, 2x minus 5. All right, and then one other kind of stupid question that how did that turn into a 2x plus 5 on the end?
Yeah. So when I distribute the -1, the green circle, through the what's in yellow, a -1 times 2x gives me a -2x right there. And then a -1 times a -5 gives me a +5.
All right.
So the second part with my 2 arrows came from multiplying -1 times 2x minus 5. The first 2x just came from the first fraction of 2x.
All right. That's my biggest issue with this is, boy, the
No,
it
they
seems
are
like the
very,
rules are being made up fast and furious as we go.
no, it's the same rules we've been using. The only thing that looks different is because it's letters, right? Just to show you that it is the same rules, right? If I have 1/2 minus 1/3, I can't do anything with those fractions until I make a common denominator. So I multiply him by 3. Well, what I do to the bottom, I have to do to the top, which gives me 3/6. Well, to get him to be a 6, I have to multiply him by 2, and I have to multiply him by 2 because what I do to the bottom, I do to the top, which gives me a 2. Dang, the eraser's 2/6. And now I subtract them. Well, when I subtract, the bottom number doesn't change. 3 minus 2 is 1. We've always been doing this, so there's no new rules. The only thing that's messing it up is because there is a variable in there. I have to keep the variable separate because he's not a like term, so therefore I can't combine them. So we actually haven't learned a new rule. It just looks weird once I put an X on this thing, right? So say this was X over 2 and X over 3. I still have to get that common denominator of 6 on the bottom. Well, 3x minus 2x is just x, and the answer becomes x/6. That's what's making it look so horrible, is we're putting all these variables in it, but we're just applying the rules of arithmetic we've been always doing.
All right. So when we get this test, the material on this test is probably going to really focus on sections 6.6 and 6.7, and not so much what was done at the beginning of the chapter, other than that stuff kind of built up to it.
Correct. There'll probably be a couple factoring, just generic factoring problems, just to make sure I can see that you can factor. But yes, what I'll probably end up doing is picking a couple problems from 6.2, 6.3 of just factoring. Then I'll probably pick a couple problems from 6.5 and 6.6, because if add and subtract fractions, you have to be able to multiply and divide them. So yeah, it'll probably be about 6 problems from chapter 6 and probably about 4 problems from chapter 10. I mean, sorry, not chapter 10, chapter 7. I don't know why I said 10.
All right. All right.
Yeah, I'm probably going to simplify this test down way more than the one I give in the classroom. I'll put way less problems because I know people are not going to have the time. So that's probably what I'll probably do, is pick about 6 problems from chapter 6, 4 problems from chapter 10, and see how it goes from there. I mean, chapter 7. Why do I keep saying chapter 10? 4 from 7, because 6 plus 4 is 10. That's why I keep saying 10. So 6 from 6, 4 from 7, for a total of 10 questions is what I'm going to go probably lean towards. I haven't built it yet, but that's probably what I'm going to do, because these problems do take a little while to do.
All right, then. All right.
All right?
Yeah, that's.
No problem, Jim. Any other questions?